Okay, hi student. Today I would like to teach you 3.2 Nernst equation. So what is function for Nernst equation? Nernst equation is used to calculate the cell potential. So where is the E cell for the concentration and partial pressure other than standard state value. So meaning that at 3.1 we learned about the all condition is in 1 molar and 1 atm for gas. But sometimes the experiment is not in the 1 molar and 1 atm. How are we going to measure the electromotive force? Yeah, so what we measure now is a E cell. So E cell, yeah, is not the E naught cell. So what's function for E cell is measure the electromotive force between the two electrodes under the not standard condition, meaning that is maybe not 1 molar or maybe not 1 atm. So the E cell of a water cell is affected by changing of temperature and concentration of solution involved. So this is a formula we apply. E cell equals to E naught cell minus RT and F along Q. So what is a Q? Q is a product over reactant. So E cell is a different potential. E naught cell is a different potential at according to standard condition. And RT and F, I think you know this one. Okay, so long Q. So what is a Q? Q is referred to the concentration of the pressure. So when you write the Q, you will write out the power according to the stoichiometry. And the Q is not include the liquid and not include the solid. So let's say for the example 1, let's say I will write the product. Product, this is solid, so not include. This is aqueous, yes. So that's why I write the C, cadmium 2 plus. And then this is aqueous, yeah. That's why I write the CAG plus and power of 2 because 2 more. And the cadmium solid so not include. Okay, how about another example involve the gas? Okay, let's say I'm using this example. Aqueous produce Fe2 plus aqueous plus H2 gas. Okay, class, yes, gas include in your Q, but we're using the symbol is a pH2 power of 1 because 1 more times the concentration of Fe2 plus because aqueous, and then solid not include and aqueous is include. So divide by the H plus power of the 2. Yeah, so this is how we write the Q. So after that, so scientists try to get the simple formula where they substitute the this one temperature in the 298 K, and then the R is 8.314, F is 96500 column. So at the end, right, they substitute in this formula 2.0303 RT and F. They substitute here. At the end, you will get the simple terms equals 0.0592 over N log Q. So always remember N is how many number they transfer. It means how many number they lost electron or gain electron. Q is referred to the reactant over product. Okay, now what's the function of a Nernst equation? Is divided by 4. First one will calculate the cell potential EMF, or we call E cell. Number 2, determine the concentration or partial pressure for the species in electrolyte. Number 3, determine the spontaneity of cell reaction. That means the reaction is spontaneous or non-spontaneous. Last one is to determine the equilibrium constant K when the E cell equals to 0. So how we start to calculate or solve the problem involve the Nernst equation? First, student must write the half cell and overall reaction. Why? Because you will write the Q based to the overall. So if you didn't write the overall, you will make the mistake. So number 2, from the overall and half cell, we can determine the M. And number 3 is we can calculate the E naught cell. And the last one, we can using the formula to get the information you want. Okay, now continue with the Nernst equation. We focus the first function is to calculate the cell potential EMF or called E cell. Cell potential is a E cell because it's not contained standard. So if a standard is a E naught cell, so cell potential refer to E cell. Okay, now I will discuss the two examples. So a cell employed is the following half reaction, nickel and chromium 3 plus. Calculate the cell potential when nickel is a 1 times 10 power negative 4 and chromium is a 2 times 10 minus 3 molar. So you can find that concentration is not at 1 molar. Either one so now it's both also not at 1 molar, meaning that this one must in the non-standard condition. So the cell potential is referred to the Ecell. Alright, okay, now to start the calculation, first one, student must write the equation, half reaction and the overall reaction. Okay, now we apply the concept at chapter 3.1. More positive is cathode reduction. So we found more positive is which one? So yes, it's a negative 0.25. So the inert more positive, that means this is a reduction, and this one happened at cathode. And this is a more negative, and this is a oxidation and happen at the anode. Okay, so student, you can write the half equation first and overall. Okay, for step 1. Okay, now for the anode, so the equation is a chromium solid produce a chromium 3 plus aqueous plus 3 electron reduction, and then number 2 is a cathode is a nickel 2 plus aqueous plus 2 electron produce a nickel solid. Okay, now so okay, check again. This is 3 and this is a 2. That means we need to times the 2, and here you must times the 3 to get the balance electron. So the overall is 2 Cl solid plus 3 nickel 2 plus aqueous, and then produce a Cl3 plus aqueous, and then plus the nickel 2 chromium 3 plus, and then this is a 3 nickel solid. So this is the overall of the equation. Okay, this is first step. Second step is your calculate the inert cell. So inert cell equals to the inert cathode minus inert anode. So the cathode now is nickel, so negative 0.25 watt minus 0.74 watt. So at the end you will get the answer is positive 0.49 watt. Okay, then so after that we'll apply the Nernst equation. So the step, E cell equals to the inert cell minus 0.0592 over n log Q. So you must substitute what is your Q. So Q is a product over reactant. So product is over reactant. So the answer is chromium 3 plus power of 2. We call this one aqueous. So I'll just choose the aqueous, and solid cannot, or I choose aqueous and chromium solid is not involved. So you will get the answer is over, and the nickel 2 plus and power of 3. So then you state here the answer for the n equals to 6. Okay, now we substitute all the information. So E cell equals to the positive 0.49 watt minus 0.0592 over 6 log chromium. Okay, now the chromium now is 2.0 times 10 minus 3 power of 2 over, okay, it's on 3 over the nickel is 1.0 times 10 minus 4 power of the 3. Okay, bracket. Okay, now student, can you show your calculate the calculation? So don't forget this is a bracket overall. So at the end you will get the answer. Ecell equals to the positive 0.42 watt.